Welcome to another SME Media webinar. I'm David Muller, Senior Editor. Today we'll explore the topic, Introduction to Sustainability. This presentation is sponsored by Drive Aluminum, and we are lucky to be joined by technical leaders from the Aluminum Association and its Aluminum Transportation Group. Now, before I turn things over, I'd like to review a few housekeeping items for our attendees. If you look to the right side of your screen, you'll find a question and answer box. If at any time during the presentation you'd like to ask a question, type it in that question and answer box, and we'll answer it at the end of our presentation. If we don't get to all the questions before the webinar wraps up, any unanswered questions will be responded to via email. Also, if you experience any technical issues, like a loss of sound, please use that Q&A box to alert us, and we'll respond to you individually with the suggested fix. If you're not able to regain access to the live webinar, or if you have to jump off early, this presentation will be available in recorded form at about 4 p.m. Eastern today. You can watch the webinar as many times as you like. All you need to do is sign in with the credentials you used to join today. Feel free to share those credentials with any colleagues who might also benefit from this webinar and this topic. Now, it's my pleasure to turn things over to Mario Greco, Global Technology Director for Automotive at Novelis. We're happy to have you. Welcome to the webinar, Mario.
Thank you, David, and welcome and good afternoon to everyone on the webinar today. Before I introduce some of our speakers that will really handle the bulk of the presentation, I did want to guide a little bit in terms of this second edition of our series in webinars. Myself, for those that don't know me already, I have the pleasure of hosting the previous one. I'm the Global Technology Director for Automotive at Novelis and also Vice Chair of the Aluminum Transportation Group in the Aluminum Association. As such, a little bit of background on the association for those that may not be aware. Really, it's a consortium of upstream and downstream producers of aluminum value-added product and semi-fabricated products, as well as primary, contributing to all of the investments and really the growth that the end markets are creating in terms of demand for aluminum, whether it's automotive in particular that we're going to talk about today based on electrification and other aspects of the changing environment in automobiles, but obviously many other end markets such as beverage packaging, aerospace, and so on. Within that, today, though, you are going to hear specifically from the staff of the Aluminum Transportation Group. And this is a dedicated set of members devoted to their end products in transportation. And really here we're focused on supporting the automotive industry specifically in how they need to solve their problems and their objectives as they confront the challenges of their changing market environment, and really focused on both the value and the benefits of lightweighting in those vehicles and those solutions, as well now more than ever on the sustainability aspects of those vehicles. And really, these full members, as well as advisory members, we have a common approach that is data-centric, and today the objective from the speakers is really to help talk a little bit about that data and our roadmap of information and knowledge sharing to help those transportation end markets. So without further ado, I'd like to introduce just a couple elements on those pathways that the team is going to talk about. So first and foremost, one of the things in our roadmap is that decarbonization of aluminum, really focused on how we are increasing recycled content for different alloys dedicated in the automotive industry. As I just mentioned now, more than ever, that growing element of the value proposition of how these products and material selections contribute to decarbonization of the overall vehicle. Because of that, it's really important that the overall life cycle of the vehicle is considered, not just the production. And really from the standpoint of how manufacturers need to look at this, it's important that they can rely on consistent data and methodologies and information to establish their own LCA analysis and objectives. And lastly, you're going to hear about developing high-speed, high-volume sorting and recycling technologies, again, in relationship to that first pathway. How do we enable really the cost-effective and appropriate selection of materials that could contribute to this overall journey? Really, the experts in that, I'll really jump to in finally introducing those folks. The first will be Chuck Johnson. It gives me great pleasure really to work on a constant basis with Chuck as president of the Aluminum Association. Chuck serves as really the chief advocate for the full aluminum value chain in the U.S. and really to support hundreds of thousands of American workers across our industry. The association, as I mentioned, has 120 plus members, which make approximately 70% of the aluminum. And Chuck's leadership in this role has helped us really to focus in on the needs of the market space. The second speaker you're going to hear from is Marshall Wang. Marshall is the Senior Manager for Sustainability Programs in the Aluminum Association. Marshall serves as member of the Sustainable Aluminum Working Group and the Environment and Energy Committee of the International Aluminum Institute. He was a delegate of the Aluminum Association for the Asian Pacific Partnership on Clean Development and Climate between 2008 and 2010. And really before joining the association, Marshall worked at Yale University as a temporary researcher. And last, but certainly not least, we are going to introduce Gary Gallo. Gary is an esteemed colleague of mine at Novelis. He's currently the Senior Manager of End-of-Life Recycling Technology at Novelis, really where he focuses on identifying emerging technologies for aluminum alloy identification and segregation. As part of that work at Novelis, he helps maximize the end-of-life aluminum recycling and develop strategic partnership to advance circular recycling of aluminum. And Gary also serves inside the working group at the Aluminum Association. So with that, hopefully a brief introduction, Chuck, it gives me great pleasure to hand it over to you for leading into the bulk of the webinar.
Great. Thank you very much, Mario. I'm really happy to be here. I'm sort of excited to be here. This topic is near and dear to my heart. I spent a lot of my early career working in this area, and I'm really happy to talk about it today. And I think that in many ways, those themes that you presented earlier for today's discussion, they really give away the punchline. And that's where we're headed. But before we get there, we have to talk about the foundational research and the foundations of our platform that allow us to make credible claims in this area. You know, the Aluminum Association and our members have been at the forefront of materials working on carbon accounting and carbon methodology for around 2 decades. And we have found over time that the work has changed. So, and I'll just briefly talk about this history. You know, going back 2 decades, the material industries really started this odyssey by looking at the carbon impact of production of materials, from extraction through purification to the fabrication of products. We were looking at the production phase of a product and looking at what it takes to make a product. And that was true also in the automotive industry. And that was the first look we really had, is how much carbon does it take to make these products? The second phase, though, extended that work, and we started looking very seriously about the use phase of products, and we found some very surprising things there along the way. And for almost a decade, the material industries and a lot of our major product areas, they focused in that area, and we looked at use phase. And now, though, in this third phase we've entered in the last few years, more and more industries are not just looking at the impact of production and use and even end of life. We're looking into the future and making predictive pathways so that we can see how decarbonization can occur in a much more proactive manner. And that's really what the North American Decarbonization Roadmap is. And I'm really excited to sort of talk through a little bit of this today. So first and foremost, this is a North American Regional Decarbonization Roadmap. It does build on the work done around the globe. The International Aluminium Institute completed a few years ago a decarbonization roadmap for the global aluminum industry, very much focused on the upstream. That work has been regionalized in Europe, and now the North American roadmap is the third entry into this foray. and that's important because regionality matters, and I'm going to speak to that in a moment. It matters not just because of what you may want to brag about in your region, but it matters more importantly in how you focus your efforts in your region. And I'm going to talk about that just a little bit more in a moment. So what the roadmap does is it takes the International Energy Agency's pathway toward the Science-Based Target Initiative approach to say, what kind of pathway can we lay out, fitting our industry to a curve that has been set for all global industries looking out to 2050 to adhere to a 1.5 degree scenario for the globe. And so it's a project that fits the industry and our production to a curve. It's our best guess at the technologies and the policies that will be needed to get from where we are today to where we will be in the future. And the first part of that is predicting what we'll be making in the future. So before you can decide what you're going to decarbonize, you have to make certain assumptions about what we will be using. And we already have an incredible advantage and disadvantage in the aluminum industry because in the automotive industry, but also in our other major markets, beverage containers and building and construction, what we're seeing is that there's going to be an incredible increase in the use of aluminum around the globe between now and 2050. So in the time frame when we're expecting demand to increase 80%, we are being asked to decarbonize our industry by much more than 90%. And so it's a daunting path we have before us. And we can't set forth on it without doing the work and looking to see both where our carbon emissions are today and what technologies and policies will lead to decarbonization in those areas. And here's what we found. We found that when we looked at where our carbon is today, it resides in the energy we use and certain technologies that we use to produce the metal. And so these are the places that we have to focus on when we look out into the future to decarbonize. So first, we already have focus in these areas and we are already working in these areas. And we're going to talk about some of these further. But in general, what we have found is that there are a basket of technologies that we can focus on in our facilities. And these include certain decarbonization efficiencies that we can achieve in the upstream and alumina refining, but also in a lot of efficiencies that we can focus on as we melt our metal, so melting technologies, and also in areas where we can decarbonize the last fraction that is not related to our energy input of our smelting technologies. And I'm referring there to the decarbonization of our electrolytic process, which currently uses a carbon-based anode for that process. That's in the smelting of aluminum. And we are in the process of a major technology shift in our industry here in North America, where we are exploring inert anode technology. So that's that first fraction. But then, as we look further, and I think this will surprise no one, we have found that 2/3 of our carbon potential, and thus our carbon mitigation, is in the energy that we use for our processes. And this is true globally. And the regional truth we have in North America is a bit different. So globally, decarbonizing the electricity that is used to smelt our metal is going to be a major focus for the global industry. But the first big difference between the global industry and North America is that we've already largely achieved that end. 75% of the primary or virgin metal that is used in North American production is already being produced with low and no carbon energy. And that 75% comes from Canada, which is hydroelectrically powered. And so that already tells us first that the first low-hanging fruit that the world is going to focus on has already been achieved in North America. And it also lets us refocus our efforts not on decarbonizing the electricity used for smelting, but instead on decarbonizing the last fraction of electricity used more generally in our industry, and much more importantly, on decarbonizing the natural gas that is used to fire our furnaces. And so we will be looking between now and 2050, and we have laid out these pathways in this report for ways that we can decarbonize our melting and heat technologies, We'll be deploying more electric arc furnaces in the future that can be powered directly from electricity when that electricity is itself decarbonized. And we'll be looking at technologies to utilize cleaner natural gas technologies and hydrogen as an alternative fuel. And this will be where we'll be focusing in the future. And what does that look like for North America? Well, as I said, North America has two major advantages as an aluminum producing region. First, as I said, we source almost all of the primary metal that we use in North America from low and no carbon smelters in Canada. And the second major advantage we have is that North America, along with Europe, has one of the most mature aluminum inventories in the world. Aluminum is a very young metal, but it has been produced at quantity for a longer period of time in the United States and North America, and also in Europe. And because of that, we have a very mature inventory of aluminum that we can draw upon for remelt metal. And so last year in the United States, around 80% of the metal that we fabricated with was recycled aluminum. And we want to increase that in the future. And so as you look at this graph, that means that between those two advantages, production of auto parts, but also beverage containers and building and construction products in North America is 50% less carbon intensive, that's your green line, than production of those same products in the rest of the world. And when you look at production in China, we are 2.5 times, 250% less carbon intensive than production in China. And that means that as we look forward, it will take 8 years if decarbonization pathways are followed in the rest of the world, and particularly in China. It will take them 8 years to reach the carbon intensity for aluminum production that we enjoy today. And by that time, as you look at the green line, you see that we will have raced ahead. So there is an enormous carbon advantage for aluminum production in North America. It is an advantage that we intend to capitalize on, and we have already done so. And there's a major reason for that. It's because, again, those products that we are producing in North America are being used in your markets to decarbonize your end products. And so we feel that we have an enormous responsibility to be active in this space. Now, I'm in danger of running long, so I'll move along here. Another way that we plan to race ahead is to capitalize on the role of recycling. It takes around 5% of the energy to remelt aluminum as it does to make it from virgin material. And that differential is greater for aluminum than it is for any other basic material. And so it makes the advantage of recycling aluminum much greater than it is for other materials. And we did a sensitivity analysis in this report to look at where we are and what recycling contributes to decarbonization, and to also look at where we could be if we were recycling all of the available aluminum in the North American market. We already do a very good job in the automotive world, in the building and construction world. At end of life, we're bringing back more than 90% of the aluminum at end of life from transportation and from building and construction. But North America is far, far behind the rest of the developed world when it comes to recycling consumer beverage cans. We only in the United States recycle around 50% of beverage cans. That's 12 packs per man, woman, and child per year of aluminum that we are throwing away in landfill. It's $1 billion of economic impact on our industry, $1 billion worth of material value that we are putting in landfills. And we have to have that metal back, not just because it's the wrong thing to do, to throw away a recyclable material, but because as a material input into our processes, we have to have this metal. We have invested in expansions in North America, as Mario said, of around $10 billion, and those furnaces will have to have metal. And so we are focusing very hard in our policy efforts to increase used beverage can recycling in North America. We will continue to do so, and anything that your companies can do or might do to help would be appreciated. When we look directly, though, at the automotive world, we're going to talk about this more in a moment. There's still more we can do there as well. There are fractions of aluminum lost in the recovery stream that we can improve upon, and there are efficiencies we can achieve in the remelt process through better management of our alloys and alloy families that we can discuss. And I look forward to that conversation as we move forward today. With that said, there's much that we will be doing in the very near future. We will be partnering with our energy providers. And I want to also say that we feel a great responsibility for the energy we use in our processes, and we will partner aggressively with the government and with our suppliers to make sure that decarbonization occurs in those streams. But we don't make that energy. And so this will take an all of society approach. We will do everything we can to ensure that we are sourcing low and no carbon energy in the future, but those options have to be available and fairly priced. And so we are very heartened by what we have seen done by the federal government recently in this area, and we will agitate for more of that in the future. I won't go into all of these policy endpoints because now I would like to turn this over to Marshall Wang to dig a little deeper into some of those issues that I brought up. Marshall, over to you.
Thank you very much, Chuck. Good afternoon, everybody, and thanks for your participation of the webinar. My name is Marshall Wang. I'm a Senior Manager for Sustainability Programs at the Aluminum Association. So my part of the presentation today I'm going to focus on is on several sustainability indicators that can reflect the automotive aluminum's contribution to sustainability from our industry to the downstream customers and to the consumers. We call these indicators as key performance indicators, and then we're working to monitor the indicators, and then we are working to improve the indicators. So these indicators are a reflection of a full life cycle thinking of the aluminum industry dealing with sustainability issues and dealing with long-term environmental impact issues. Life cycle is an important perspective in terms of environmental management. The aluminum industry, and as well as the automotive industry, is working on improving the life cycle performance of the products, because for a product like a car, it is a very special consumer product. First, they use a lot of materials in the production processes, but the vast majority of the environmental impact happens at the use phase, which is on road. So that's why we're looking at a life cycle perspective to manage our sustainability programs. Before I jump into the indicators, I want to talk a little bit about the terminology so that you can get a better understanding when you see the parameters. First, let me talk about what is a life cycle assessment. A life cycle assessment is an environmental assessment tool to assess the potential environmental impact of a product throughout its entire life cycle, from raw material extraction to the end-of-life recycling or material disposal. So that is a terminology that you should keep in mind. And then another terminology that's going to be involved is called the cradle-to-gate environmental footprint. So cradle-to-gate environmental footprint, in simple way to speak, is really the production stage of the environmental footprint of a product. And then we have another terminology called cradle-to-grave environmental footprint. That is the full life cycle environmental footprint that should include the use phase, and then also should include the end-of-life phases of the product. An illustration of an automobile is here, so that you can take a look at, from the raw material extraction to manufacturing to the use and to the end-of-life phases. Life cycle assessment examples are plenty. There are almost all market sectors and the industries and the players are doing LCA these days to figure out what is the true environmental footprint of a product. For automotive products, here are the two examples that you can find out online. one example is a study sponsored by the Aluminum Association and conducted by the Oak Ridge National Lab a decade ago. That study was comparing aluminum lightweighting solutions versus the lightweighting solutions of vehicles by using advanced high-strength steel. As you can see, that aluminum has a full advantage over the entire life cycle, has a lower footprint than the alternative solution. Another example posted here is a recent Revance study. So in that study, they compare different designs. They compare their newly designed cars with the previous generations, and then they show that 15% reduction in full life cycle footprint. So these are the examples that you can take online. But the sustainability indicators that I'm going to cover today, the first one is called the recycled content. As Chuck has mentioned previously, using recycled material saves energy and reduces life cycle footprint of the product itself. So for automotive aluminum, we want to figure out what is the current industry average on recycled content on different forms of the products. So we conducted surveys and then we compiled information all together and we published reports. So as you can see, different forms of automotive aluminum products has different recycled contents. Some of the materials, they have a lower recycled content because the material, the products is much younger compared to the other products, which is the foundry products that you find here. So by the way, we ship three major different forms of product to the automotive customers: automotive sheet, extruded automotive profiles, and foundry products, which is basically the engine blocks and the powertrain houses and things like that. So the next sustainability indicators is referred to a term called end-of-life recycling rate. This is about the percentage of a material recovered during the end-of-life recycling process. A higher recycling rate means that the material performs better because we recover more of them, and we have so that we can use them as a future feedstock for making new products with recycled material, and we can also avoid in producing primary materials in the future. So we have conducted a study a decade ago focusing on what happens with the aluminum recovery in automotive during the end of life of vehicles. We have found out that when the vehicles is set to be recycled and recovered in a material facility, in the shredders facilities, the vast majority of aluminum is recovered. There's very little loss in the recovery process. As you can see that the loss is basically several percentage points. So aluminum, qualitatively, automotive aluminum is very well recovered and recycled at the end of life. However, from a qualitative perspective, you will hear on the next speaker talk about how the aluminum industry is working to improve and what we call it an upcycle process to keep up the value of the material. So the next sustainability indicators is focusing on the production stage environmental footprint of aluminum products. So we call it cradle to gate carbon footprint or energy footprint. Carbon footprint and energy footprint are here to use as an example, but there are other environmental indicators that are in very similar scale. So for the different aluminum products that are shipped to the automotive market, we have conducted studies to figure out what is the carbon footprint on average and what is the energy footprint on average. Here are the numbers that you can see. In particular, the production stage environmental footprint is correlated to the level of recycled material usage. As you can see, automotive sheet has a higher footprint because it has a lower recycled content. Foundry products has a lower footprint because it has a much higher recycled content. The next indicator that we are monitoring and looking for is the what we call the cradle to grave carbon footprint and energy footprint. Over here, we're looking at the full life cycle with the use phase being excluded because we assume that in the use phase, aluminum products in a car remains the same, and very little repairing or replacement is required because the vast majority of the metal is strong and they keep together with the full life cycle, with the full lifetime of the vehicle. So over here, we included the end-of-life recycling scenario. As you can see, these footprint numbers are a lot lower than the previous cradle-to-gate footprint. Why? Because once the material is recycled at the end of life, the material recovery receives a credit to offset the manufacturing stage footprint so that the net environmental footprint of these products can be reflected in a full life cycle perspective. And that gives us a very good snapshot of a material's performance in terms of their attributions to the environment. The next indicator that we are monitoring is called the semi-fabrication yield. So aluminum is a raw material, but we need to make them into a product through metalworking process. So different metalworking processes has different efficiencies. They're decided by the nature of the processing, not by the individual company's performance, but largely by the nature of the processing technologies. So as you can see, to produce automotive sheet for the same amount of metal that goes into the product, your yield is lower than foundry products because in a rolling process, you generate a lot of scrap. So the industry is working to improve this efficiency, and these efficiencies are indirectly related to the manufacturing stage environmental footprint of the products. As long as we make progress in the future, we will make smaller progress in reducing. We will make gradual progress in reducing the manufacturing stage footprint. So the other life cycle sustainability indicators for automotive aluminum that we are tracking is what we call the lightweighting potential. These are determined by science, by physics. As you know, aluminum is one of the best lightweighting materials. It's strong and it's lightweight. You use aluminum to make a vehicle with a lighter weight. You will end up with a better fuel efficiency of the vehicle. The Department of Energy has conducted a lot of physics studies and trying to figure out what is the potential of aluminum lightweighting in replacing automotive steel. And here are the potentials that they listed in their studies, aluminum has the potential to reduce the vehicle part weight or system weight by 30 to 60%, depending on the designs of the vehicle, and depending on the designs of the system, so depending on the grade of the automotive aluminum that you use in your vehicles. So overall, this is one of the best lightweighting materials. It's not only has great potential, but it's also economically very well positioned, probably the best economic materials to do lightweighting for automotive. The last sustainability indicators that we're monitoring is the contribution of lightweighting for aluminum in reducing vehicle energy consumptions during the use phase. Over here, you can see there's a range of these potentials. So these are quantitative savings for aluminum lightweighting for ICE vehicles. Hybrid and electrical vehicles would have different numbers over here. But this is solely about ICE vehicles. The powertrain is the gasoline engine. And over here, you can see that there's a range. So this range, the lower range and the upper range, is depending on whether the lightweighting will trigger a downsizing of the powertrain, reducing the engine size so that you can maintain the performance, but have much larger fuel savings. Or if you say, okay, I'm designing a car with performance in mind, and I want to use lightweight aluminum to improve the performance of the vehicle, then you have would have a smaller fuel savings on the road. We as an industry expect that these savings will be improved in the future as the industry developing better materials and better alloys to serve the automotive industry. So these are the indicators that the aluminum industry has been using to monitor the performance of automotive aluminum. We are expecting that these indicators will be updated in the future, and we're going to be working on to keep monitoring the progress. So in summary, the U.S. made automotive aluminum has a very low environmental impact already over the life cycle, and aluminum as a lightweight material can help reduce the vehicle's environmental impact over the full life cycle. And we encourage users to look at an Aluminum Association's data, particularly for aluminum when you do life cycle assessment for your vehicles, because data matters a lot when you do LCAs. Different people can use the same thing to claim different stories, but at the end of the day, you need to use accurate data to perform a life cycle assessment. And lastly, we're focusing on the full life cycle story, and we're focusing on prioritize accurate and transparent information to serve the automotive industry and to improve aluminum's sustainability performance. With that, I will give the stage to our next speaker, Gary Gallo.
Right. Thanks, Marshall. So now, armed with all this knowledge on the sustainability benefits of aluminum's usage in automotive, let's test your expertise for the poll question. Get some audience participation. when compared to the production of primary aluminum from ore, how much energy can be saved when using recycled or secondary aluminum? And you have the opportunity to choose four options. We'll keep this poll question up for a bit and then advance to the results. Hopefully, we can bring this to a close faster than Arizona and Nevada have brought their election results forth. And see what the participation looks like here. Give it a couple more seconds. All right. I'm not sure how many folks are actually participating in this, but let's move forward and find out. All right, solid performance. The correct answer is 94%. So recycling aluminum consumes only 5% of the energy needed to produce primary aluminum from bauxite ore. So if you voted for 95%, you are a winner. Your prize will be in the mail. So as Mario and Chuck and Marshall have outlined earlier, the ATG and the Aluminum Association are heavily focused on reducing aluminum's carbon footprint, creating higher recycled content auto alloys, and developing better technology solutions for alloy segregation during recycling. And it's on this point that I wanted to spend a couple of minutes today to do a high-level introduction into the current state of recycling and then set up for our next webinar in February, where we'll do a deep dive into end-of-life recycling and the advancements in aluminum alloy segregation technology. So let's first start with the current state of end-of-life, or EOL recycling, for those who may be less familiar with the process. Take a look at two slides here that show the current state and the future state, and then a final slide with some additional detail. At a high level, this shows the current state view of what we're referring to as downcycling, what Marshall referenced earlier. Now, when we refer to downcycling, we mean that aluminum alloys are not fully recycled back into their original alloys. While all aluminum is recycled back into aluminum in the automotive recycling process, it's not all recycled back into that original alloy. And looking at this slide and thinking about the automobile at the end of its service life, the vehicle is currently shredded in a 6,000 to 10,000 horsepower machine that rips the vehicle apart, effectively disassembling it to prepare the metallics for segregation and recycling. The aluminum refraction is referred to as something called twitch. It's an industry term and consists of cast parts, think engine blocks and transmission housings, and wrought parts, think hoods, extrusion, and deck lids. So if you think about what comes off of a shredder, there's a piece of metal that looks about like that. It's a piece of aluminum. This twitch is then sent for processing at a secondary aluminum producer to make alloys like A380, A356, or ADC12, which are then remelted into finished products like wheels, engine blocks, and transmission housings. In this current state scenario, all of the sheet and extrusion, or wrought aluminum, is recycled into cast alloys. And once recycled in this way, the wrought fraction becomes a permanent part of the cast aluminum ecosystem, and we lose it forever. This is why we refer to this as downcycling. While still infinitely recyclable, the silicon levels of cast scrap prevent it from being recycled into sheet and extrusion products. So without access to this scrap, sheet and extrusion producers use primary aluminum and hardeners to make up the difference, something that represents a direct challenge to the industry's sustainability and carbon reduction goals, and thus the reason for our focus on it. The solution to this challenge centers around technology. More of this in a minute. In the future state, advanced scrap alloy segregation technologies are applied to twitch to divide it into its constituent parts, cast, sheet, and extrusion. For this reason, this is referred to as upcycling, or recycling like alloys into like alloys. With access to this new segregated scrap streams, all aluminum producers, whether cast, sheet, or extrusion, benefit from the increased access to scrap and the carbon reduction it affords. So let's take a slightly deeper dive into twitch. If you look closely at this composite photo, what do you see? Probably appliances, machinery, gas grill, perhaps a bike, and yes, cars. Everything in this photo is feedstock for a shredder. So while an auto shredder does prepare cars for recycling, it also shreds so much more, which creates a wide range of aluminum alloys inside of twitch. The graphic, sorry about that. A couple of notes on twitch specifically. Virtually all twitch is downcycled into casting. So it is recycled, but it is downcycled. Most twitch out of the United States or North America is exported. And there are, however, on the good news side, lots of new partnerships that are emerging in technology development that we'll talk about here in a second and again in February. So the graphic here shows at a high level the view of end-of-life recycling for autos and everything else that goes through a shredder. This process is well established at scrap processors and recyclers around the world and has been in place since the 1960s. As you look at the process flow, recall that something approaching 97% of all the metallics generated in the shredding process are currently recycled. At the first stage, there is some disassembly, like removing 356 wheels and catalytic converters. Once stripped, the vehicle is dismantled via shredding, and the non-metallic portion is removed, followed by steel recovery via magnetic separation. Eddy currents and X-rays then sort out the non-ferrous streams of copper, stainless, manganese. In the future state, aluminum twitch will be segregated into cast, extrusion, and sheet via the use of optical AI, X-ray, and LIVS, which is an acronym for laser-induced breakdown spectroscopy. It's these later stage alloy segregation technology partnerships that are developing now and will be the topic of our February webinar. So until we talk in February, I'll pass this back to Mario to navigate some questions.
Thank you, Gary. So yeah, some interesting information presented across these three different pathways. We had a couple of questions coming in, but I'll give some time for participants maybe to ask a few more. And maybe we can start with Chuck, on your side. You just kind of to talk about a little bit what those investments in the aluminum industry have been, which ones we made. I know we talked about it in the lead-in and then you mentioned it, but maybe give a little bit more detail, particularly in reference to decarbonization investment.
I'm sorry, Mario, you cut out for a moment when you asked that question and I didn't get it. Could you please restate it? I apologize.
No worries at all. Hopefully you can hear me okay. It was in relation to investment specifics about investments that the industry might be making in the realm of decarbonization.
Thank you very much. The investments in decarbonization are on several fronts. First and foremost, in North America, the industry is investing in remelt capacity. And so increasing our remelt capacity gives us the headroom as demand increases to service that demand with remelted aluminum and not increase our primary fraction. So that's a very significant sort of structural investment in the industry. But then when you look more granularly within the industry, there are certain investments that are specifically aimed towards increasing the efficiency and the carbon profile of existing capacity. And so those investments are in the categories of energy portfolio diversification, including some on-site investment for energy production, and in remelt technology. And in that basket, I think we are exploring investments in hydrogen, either as an additive fuel or as a fuel source. And then in looking at other forms of process heat technology, including furnace technologies such as electric arc furnaces. There are many other examples, but those are some of the big categories that I would point out in the U.S. industry today. Now, also, I should go without saying, I already mentioned ELYSIS technology. That is an important sort of that's an important advancement in the it's a sort of sea change advancement in the technology that is used for smelting our metal. It'll be the biggest advancement made in that part of our industry in decades.
Yeah, great. Thank you, Chuck. And in actually just kind of leading off from that last statement, there's a question from Xavier Walls, and maybe Marshall, this is something that you can help a little bit address, but just diving into who are some of those organizations that have been basically investing in that inert anode technology, and really, where can maybe people find a little bit more information around that technology and the feasibility of these technologies at the moment? And maybe even if we can point out some of the ones in Canada that are doing that.
Absolutely. So those investments are being made on the industry side by many of the players in the industry. And I'm happy to report that a majority of the Aluminum Association's members have invested in some way in this area in their processes. But starting with the upstream, Alcoa and Rio Tinto and the major smelters in North America are all in a joint project. They have been joined with federal investment, both in Canada and in the United States. In the United States, we are very, very supportive of the investments that the federal government has made along with us through the Inflation Reduction Act. And those grants and those funds have gone to many, many of the players in the North American industry, from Novelis and Hydro, and I could give you a laundry list, and we would be happy to do so, but I won't try to list them exhaustively here. And then finally, I think it's also important to note that there are investments of time and effort. We applaud the energy that has been brought to us by the nonprofit community and the academic community in this area. We have partnered aggressively with those two sectors in exploring these advancements.
Very good. So maybe taking a step in slightly a different pathway. And Gary, this might be an area where you can help out. I think there's a question from a gentleman here, and actually I'll combine it with kind of a little bit of the lead-in to how you spoke about your area. But if someone wants to understand where does the industry really start with this transition to the future sortation technologies, can you discuss that a little bit? But in particular, there's a specific question about, will these products perhaps be identified or basically come with what I believe the question would be a certification or identification to distinguish them from their normal products in the end?
Mm-hmm. Yeah, good question on both counts. So let's start with the last one first. If you look at alloy segregation by product, there's a couple of different technologies that exist today to do that. X-ray, XRT, XRF are a good first step, but can't currently get us to the alloy-specific family. So we might be able to separate 3s, 5s, and 6s at a high level, but then in order to get to, say, a 5182 versus a 6111, we might need additional technology that comes in the form of libs or variants of an XRT type system. That technology is already in place, and it can clearly identify for us the alloy and we would know based on the input stream whether it was end of life or new production. And currently we're doing segregation on the new production side already. But that leads into, I think your first part of the question is what needs to happen in terms of industry adoption. This is currently market disruption. It's not happening today for a variety of reasons, but clearly the industry is moving in that direction. At the Aluminum Association's annual meeting just a few weeks ago in Washington, there was a lot of discussion around this topic from members who realized the benefit of segregating this scrap for carbon reduction goals. The three things that really need to happen: first, the continuation of partnerships with technology providers to be able to create the solution to do the alloy segregation first. The second is for consumers of that product, whether they're aluminum mills, billet casters, die casters, to create specifications around it. Then that third, allow the scrap industry to become the active participants that we need them to be, and we know that they want to be able to provide this product, for us. Recall, all this aluminum is already going through their shredders, and what we're looking to do is bolt some additional equipment, perhaps on the back end, to do one more layer of segregation for us, and pay them appropriately for that.
Very good. Thank you, Gary. So I know we've reached kind of the bottom of the hour, so I think we'll kind of stop the Q&A here. We'll try to answer some of the questions maybe live or follow up with some of them, but some great questions. And David, I'll hand it back to you to wrap up.
Great. Thank you. I want to thank everyone from the Aluminum Association and the Aluminum Transportation Group for joining us today. I also want to thank our attendees for your participation. We hope you found the content valuable and will join us again soon. Until then, remember that SME and SME Media are here to help you stay up to date on all things manufacturing. You can find links to podcasts, webinars, publications, and news by visiting us at advancedmanufacturing.org. Thanks, everybody.